Hello 506 students, this is the third SPSS exercise video, and in the last video we learned how to read some basic information of variables, and we also learned how to create frequency tables and bar charts in SPSS. In this video we will learn what cross-tabulation and chi-square test are, and then learn how to run cross-tabulation and chi-square test in SPSS. As the last part, I'm going to explain how to interpret cross-tabulation and chi-square test outputs in SPSS. And before watching this exercise 3 video, please be ready to use the dataset that we used in the last exercise. The name of the dataset is 506 SPSS survey data.sav. If you're ready, let's begin. Cross-tabulation, also known as contingency table, can be defined as a table summary that displays frequency distribution of categorical variables. And as you may already know, categorical variables include nominal and ordinal variables. And you may also think this word, frequency, sounds very familiar, right? We already learned how to create a frequency table in SPSS. Then, what is the difference between frequency table and cross-tabulation? I would say the biggest difference is that a frequency table shows frequency distribution of only one variable at once, while cross-tabulation shows frequency distribution of two variables or more than two variables. And because a cross-tabulation can summarize the data of at least two variables, you can use the cross-tabulation to find a potential association between the variables. However, if we want to statistically test the relationship implied in the cross-tabulation for generalization, we need to use another statistical method that is more advanced than cross-tabulation. And one of the most popular way of testing cross-tabulation is the chi-square test. When we say chi-square test, it refers to Pearson's chi-square test of independence. But in general, we call it a chi-square test rather than Pearson's chi-square blah blah blah. And Pearson was the scholar who developed this test. And there are many other series of chi-square tests that use different formulas from Pearson's one. But because Pearson's chi-square test is the most popular one, when we say chi-square test, that means Pearson's chi-square. Anyway, chi-square test is a kind of inferential statistics. We use inferential statistics when we need to make inference about some population. And in general, studying an entire population is really difficult and expensive. And to make inference about a population, we need to test an assumption about the population. And in order to test an assumption about the population, we use a null hypothesis, which generally claims there's no relationship or no difference between certain variables in the population. And if the null hypothesis is rejected from an inferential statistical test, we can insist that there is a significant relationship between the tested variables in the population. And thus, if you want to use chi-square test as your inferential statistics, it is essential to know the basic null hypothesis of chi-square. The null hypothesis of chi-square is like this. Two categorical variables are independent in the population. And in order to easily test the null hypothesis and calculate the chi-square test values, we use cross-tabulation, which is the same as contingency table. But we don't need to worry about the calculation anyway, because SPSS will do it for us. Still, we need to know some of the procedures going on in an SPSS cross-tabulation output in order to interpret your test results. and I will explain that later in this video with actual SPSS output. So all in all, here is the one essential thing you should remember. Chi-square test examines the relationship between categorical variables in the population. Remember that chi-square variables are for categorical variables, not for interval or ratio variables. Now, let's run cross-tabulations and chi-square test in SPSS. As I said in the beginning of this video, we're gonna use the same dataset we used in the last video. So, I have already opened the dataset in SPSS. First, we're gonna create a cross-tabulation by using variable high satisfaction and high stress. So go to Analyze tab on the top menu bar and click it. And then go to Descriptive Statistics. And then click Crosstabs. And then we're gonna use high satisfaction and high stress variables. So let's look for them in the left box. There they are. First, choose high stress and put it in the row box by clicking this arrow, and then choose high life satisfaction and put it in the column box by clicking this arrow. And if you click OK now, you will get a simplest cross-tabulation, but we're gonna make a cross-tabulation more informative and get chi-square test results as well. So click the cell button here on the right. Then we can add more information on our cross-tabulation. First, we will check on the box for expected counts here and keep the box for observed count checked like this. Just keep it. And the expected counts are the hypothetically calculated numbers, assuming that two variables we chose are totally independent from each other. And by comparing the discrepancies between the expected counts and the observed counts, we can test the relationship between the tested variables in the population. I will explain this a little bit more in detail later in this video. And let's add some percentages here. If you want to see the proportions of the variable in the row, then you can click to check on the row. Or if you want to see the proportion of the variable in the column, then you can click to check on the column. However, for this exercise, I would like to see the proportions of row variable only, which is high stress. So let's just check in the row percentage box, not column box. So now click continue. Then we need to order SPSS to run chi-square test. To do so, click statistics here and check in the chi-square box here, and then click continue. Now we are all ready to see the results of the cross-tabulation and chi-square test. So click OK. Yay! We got the cross-tabulation and the chi-square test results. Now we're gonna learn how to interpret these results. But for your own exercise, I will not interpret this specific output. Instead, I will use sex variable and high stress variable in the same dataset to create another cross-tabulation and chi-square test results. So please don't forget to save this output since you're gonna need it to do your exercise. And we're going back to my presentation screen to learn how to interpret SPSS results. So here is another SPSS output for cross-tabulation and chi-square test. I went through exactly the same process we did for our SPSS exercise, but the variables I chose for this time were sex and high stress variable. To make this output, I put variable sex in the row and put variable high stress in the column in SPSS crosstab window. So first things first, before interpreting the analysis results, you need to know about the missing values. Looking into the missing values before your interpretation is very important because you should know how many cases were included in your analysis. And if you want to see the number of missing values, check the first table, Case Processing Summary. This table shows how many cases in my sample data were used to run the analysis below. So these are the outputs of the analysis I ran. And this summary shows that 433 cases were valid to run the analysis. However, the number of total cases I had in my sample data was 439. So that means I have 439 cases, but 6 cases were not used in the analysis. And as we can see here, there are 6 missing cases. These are the reason why only 433 cases were used for analysis out of 439 total cases. Now, let's look into the cross-tabulation below and explain what this table shows. It may seem complicated, but actually it is not that difficult to understand. First, let's just look into the rows with observed counts. When we see the rows, we can easily understand that there are a total of 184 males, and out of 184 males, 167 of the males did not have high level of stress, and 17 of the males had high level of stress. And if we see the row of female counts here, we can say that out of 249 females, 199 were not highly stressed out, while 50 were under high level of stress. And now let's look into the proportions as well. If we see this row that shows percentages within sex, we can say that 90.8% of male did not have high level of stress, while 9.2% of male had high level of stress. In case of female, 79.9% of female did not have high level of stress, while 20.1% of female had high level of stress. And from this result, we can simply understand that in our sample, females have much higher proportion of people who had high level of stress than male. The proportion of female who suffer from high level of stress is more than 2 times than the proportion of male. So now we know there's a difference between male and female in terms of high stress level in our sample. However, what we do not know yet is if this difference in our sample can be found in the population of our sample. In order to test this question, we need to use inferential statistics with the null hypothesis. In our situation, because the 2 variables we are testing are categorical, we can use chi-square test with the null hypothesis. And as I briefly explained in the beginning of this video, the null hypothesis of chi-square test is 2 categorical variables are independent in the population. If we apply this to our situation, our null hypothesis is that sex and high level of stress are independent from each other in the population. And the expected counts in each cell are the numbers when the null hypothesis is true. These expected numbers are just hypothetical numbers when sex and high level of stress are totally independent. And then what we need to do, actually what SPSS does for us is to compare the expected counts and the actually observed counts with a statistical method. And the statistical method we use to compare these values is chi-square test. So let's move on to the chi-square test results here. In this variable, the first thing you should check is at the bottom of the table. At the bottom, you can see a sentence, and it says 0 cells have expected counts less than 5. Is this good or bad? Actually, this is good. This is related to one of the assumptions to be met in order to use chi-square statistics. So, for a 2x2 table, all the cells with expected counts need to be larger than 5. And for a larger table than 2x2, all the cells with expected counts may have values larger than 1, and no more than 20% of all cells may have expected counts less than 5. If this assumption is not met, the chi-square test becomes inaccurate. In our case, we tested 2x2 table, and all the cells with expected counts have values much larger than 5. So these numbers are big enough to use chi-square. Now, let's look into the row of Pearson chi-square. Actually, this row is the only part you need in this table. The other parts below this chi-square row, you don't really use it. Anyway, if we see the value here, this is the chi-square value. This value shows how much the expected counts and the observed counts are different from each other. So the bigger the chi-square value, then the bigger the discrepancy. And then df here means the degrees of freedom. The degrees of freedom determines the distribution of chi-square statistics, but we don't need to know how to use this unless we manually calculate the p-value. And fortunately, SPSS do all the calculation for us, so let's just move on to the next column. The asymptotic significance here refers to p-value. P-value is used to determine if a statistical test is significant or not. And conventionally, we use the significance level less than 0.05. So if the p-value is less than 0.05, we can say that the association between tested variables was statistically significant. In our case, the p-value is 0.002. So we can definitely say there is an association between sex and high level of stress. And before we wrap it up, I'm going to show you how to report the output. So here's my writing. Among the respondents, 9.2% of males had high level of stress, whereas 20.1% of female had high level of stress. Thus, in our sample data, the proportion of females with high level of stress was more than 2 times higher than the proportion of males with high level of stress. A chi-square test of independence was conducted to examine the association between sex and high level of stress. The association between these two variables was significant. Chi-square degrees of freedom 1, the number of total valid cases is 433, and the chi-square value is 9.508, and p-value is 0.002. In this report, I firstly informed the numbers that I thought most important in the cross-tabulation. and then I kind of rephrase it in order to show what these numbers mean. And I mentioned what inferential statistics I used to test the association between the variables I was interested in. And finally, I reported if the association was statistically significant. And this symbol refers to chi-square. And the values in the parentheses are degree of freedom and the valid cases for chi-square test. And the value of 9.508 is the chi-square value, and the last one refers to p-value. Okay, we're all done for today's exercise video, and I will see you in the next video. Bye.